This video is brought to you by Sporlan. Quality, integrity, and tradition. So we've got a Kairak Blu unit that they're saying is freezing their product up on the top. So we're going to go through everything and see what we can find. We'll check our temperatures and see what happens. So the first thing I'm going to do is go ahead and get into here. This is just like a Charleston unit, even though it's a Kairak, same company. So I'm just going to get into our user settings. Our set point is 25 degrees. That seems a little low to me. The highest they'll let me go is 27. But let's go through everything else. So we're going to look at our sensors. CB says 28. EL says 17. LL says 37. So I believe the LL is my air temperature inside the box. They've reconfigured this Charleston controller, so in the past that would be a liquid line, but on this they're not using it as that because they've kind of modified this controller. This is the manufacturer. They modified a Charleston controller to work on this Kairak, so you just gotta you can't just assume it's the same as the Charleston. So we'll have to go through this and verify these sensors are actually working correctly. Okay, so on this guy right here, yeah, it's what I thought it was. We've got some bad sensors, and I'm going to show you one more time. We're going to go into the settings, and we're going to go up to, we've got CB, EL, and then LL. And like I said earlier, the LL is the air temperature. That's just for the customer to see a temperature in the box. That does not affect the operation of the unit at all. So we're concerned with CB and EL, and those sensors should be reading pretty close together. So we've got one reading 28, and we've got one reading 17, so 11 degrees off. So what's happening is those two affect the operation of the box, and they should be reading within a degree or two of the same temperatures. And so that's why we're freezing the product, is because we've got a huge temperature swing between those two. Now, where they are right now is not field replaceable, so what we end up doing, like I've showed you guys before, is relocating them into glycol elsewhere inside the box. So I'm going to go out to my truck and see if I've got some sensors right now. So this is the back side. This is our glycol pump. This is our reservoir, and that's pretty much it. So what we're going to do is we're going to go ahead and run the sensors, and they're going to go, we're going to drill a hole in the top of this cap. And the sensors are going to drop down through this reservoir all the way down into this T. And they have to be all the way down at the bottom of that T. And we just basically run both the sensors together. So that's what we're going to do. We're going to get them ran down into that right now. So to do this, I've shown it before, but I tape the sensors together because this is a little piece of 1/2 inch copper below that insulation, so it's difficult. But you notice something. You notice how it has a curl. And that's going to be difficult to try to fish down in there. So that's where the zip ties come into play. So what you do is cut a zip tie and tape it to the zip tie, and the zip tie will help to keep it straight. And you'll see what I mean when I do it right now. Now you see it has much less of a curl, so it'll be much easier to feed down into there. The next thing you're going to do is kind of mock it up and find out how far they need to go down, because it's difficult once you get them in there. And then mark on the top with like some tape or something right at this point, wherever it is, so that way once you feed it down, you know how much further you need to go, because you can't see down in here, so you're just kind of guessing once you feed them in there. So drill the hole in the cap, but I left the bleeder hole. Try not to poke the bleeder hole, so that way because you're going to seal this up with silicone, so that way it can still breathe and expand if it needed to. Once I have marked where it is, notice I put a big old fat bead of electrical tape, so that way it can't pull through the hole, so you can't get yanked out, because I've had a problem with them being yanked out. So then I got in there and just laid a little bead of silicone, and I know it's hard for you to see, but I didn't get the silicone on the breather hole on the top of that cap. So then that way we're sealed and everything's good. Got a little fitting there to keep the wires from rubbing out, and all is hunky-dory now. Dinner time. Look at that. Yummy. All right, well, we're gonna get in there and change the air temp sensor too, because I change them all at the same time. When you're working in restaurants, you'll learn that cardboard is your best friend. It protects you from all the nasties. Just don't rub your head in the stuff in the top of the box. So what you do for this sensor, there's nothing else you can do, you just splice it. So I spliced it right here. You don't want to make it too much longer. So I change all my sensors, all three at the same time. Just because they fail, the failure rate's so high, so just change them all, it's just as easy. So yeah, so I spliced that sensor in, and then that's pretty much it. We're just gonna put this unit back together now. And lastly, I would highly suggest you verify evaporator fan motor's working, which it is right now, before you put all the drawers and cages back in, because there's nothing worse than doing all that and then having to take it all back apart because your wire got stuck in the blade or something. So, and this is just going to prove it. So first off, if you see the ELELOS, that's just means it had electrical loss. But you see how it says cabinet or C47, that's that yellow sensor. And then R is 24. So this just shows you that that sensor in here and that does not affect the operation of the unit. The operation is off of the other two sensors. So those are just a dummy sensor to give the customer a digital display. So if we go up here, LL is that yellow sensor, 47. So EL is 23, CB is 24. So what they're going to do is they shut off the compressor because the glycol temperature is 24 degrees. So they're just going to let the glycol circulate through there and bring the box temp down. So see, there's no need for the compressor to run because our glycol's still, you know, at 24 degrees. So it's still nice and cold in there. And then we can go down here to see our set point of 27 degrees, and we're going to put that to the max, which is 27. They only give you so much. See, they'll let you go from 17 to 27 on this one. So we're going to leave it at the max because they're already complaining about freezing. So again, LL is 45. That's the air temp inside the box. EL is 23. CB is 24. So we're just going to let this guy run now. See what happens, and I'll clean up those sensors.
There was absolutely nothing difficult about this one. The original call was they were freezing the product in their refrigerator, and when I arrived, what I found was that the temperature sensors had failed. Okay, this particular unit is a Kairak Blu unit. Okay, so what they do is they use glycol as a secondary cooling fluid, basically. So the refrigerant cools the glycol, then the glycol runs into the box and the air flows across the glycol as a heat exchanger. Okay, so this unit has a few heat exchangers in it. You have the flat plate heat exchanger where the refrigerant heat transfer happens, and then it goes to the glycol, and then you have the glycol that's pumped via a little transfer pump, basically, and that is where the heat transfer happens with the air, and it cools the food. Okay, say what you like about these boxes or not. You know, there's goods and bads about them. The one bad thing I'll say is they take a very long time to come down to temperature, but once they do come down to temperature, they maintain that temperature very well. Where they really excel is in the pan chiller or the cold rail section up top. If any of you has experience with the older Kairak units that used to use air and they had the cold rails up top and the little fan motor, they would constantly freeze up. The drains would plug up. They were just, you know, they were very effective in high ambient kitchens, but they had a lot of problems. Well, these glycol, these blue units, they really solve all those problems, and they still do pretty well in higher ambient kitchens. I wouldn't see one of these working too well in a kitchen over 80, 85, but certainly do a lot better than a lot of other regions. So anyways, the sensors had failed. This unit has 3 sensors in it. They do one on the in, on the out of the glycol. So basically the temperature coming out of the heat exchanger, the temperature coming out of the top evaporator, and then they have an air temperature one. Okay. You would call one a temperature controller, one a defrost sensor, and then one's just a display temperature sensor. So we had a failed temperature sensor. The box thought that it was, 15 degrees warmer than it actually was inside the box, so they were freezing their product. So when this happens, it's a very common thing. They use the Trolson sensors. Again, any of you that have experience, you know that the Trolson sensors have a lot of problems. Kairak and Trolson are owned by the same company. They're kind of sister companies, so they utilize a lot of the same parts, basically. When Kairak merged with them, with Charleston, they basically abandoned most of the Kairak parts and started utilizing the majority of the Charleston parts. And you get it, they're trying to save money and stuff. But anyways, so they have the high failure rate on the sensors, just like any of the Charleston coolers do. So it's very common that these sensors go bad. And when they do go bad, I highly suggest you change them all at the same time just because of the failure rate. Same thing on a Charleston too. If I have a coil temperature sensor, I change the cabinet sensor on a Charleston. But anyways, we're going off on a tangent. Went ahead and did that. So it's really not too difficult what you have to do. But, there's some things you want to follow and some steps. I like using that zip tie trick to make sure that the probes stay in a straight line. And it's very important that when you're feeding those probes down into that glycol reservoir, that they go all the way to the bottom of that copper T that was below the insulation that I mentioned in the video. If they don't go all the way down, then they're not getting the return glycol temperature. If you just set the sensor up in the top of that little reservoir, it might temp, 4 or 5 degrees warmer than the actual flow of glycol. Okay. And the flow is the return. It's like the return air temp. Okay. So you want to get the glycol as it's moving to make sure that you get the accurate temperature inside the box. So went ahead and took care of that, relocated the sensors to the back. That's actually the way Charleston recommends it. The only other way to do it would be to pull the back of the box off and dig through insulation. And that just seems very, ridiculous. And like I said, the first time I went to go work on one of these, I called Kairak. I think I said Charleston a minute ago, but I called Kairak and I asked them, like, how the heck are you supposed to change these sensors? And they said, don't just relocate them into the glycol return stream. Problem solved. So we've been doing that for quite a while now. And I actually keep those sensors on my truck because it's a pretty high failure thing on those things. So I really appreciate you guys taking the time to watch my videos. Keep in mind, I do live streams Monday evenings. If work is permitting and I'm not too busy, I go 5 p.m. Pacific time. I go live on YouTube, and then I basically just talk about the videos that I released, answer majority of the questions. A lot of the times the questions that I get from these videos are pretty similar, so I just kind of address them usually at one time. And then I also answer other questions that people come in. There's a live chat going on. People come in there and they ask questions. There's usually somewhere between 150, 200 people in the live chat or watching the video at live basically. And so they ask questions and I try to address as many as I can. So feel free to come in and check it out. Other than that, guys, again, thank you so very much for taking the time to watch these videos. Any questions, send me an email to hvacrvideos@gmail.com. Leave it in the comments. Leave it in a Facebook comment. I'll try to get to it, okay? Other than that, we'll catch you guys on the next one, okay?